Hello everyone, welcome to Mechanical Sathi. So in this video, we are going to learn something about shear force and bending moment diagram, which is one of the most important chapters from the subject that is strength of material. So this is the first lecture for this chapter. So before going to shear force and bending moment diagram, we'll be discussing some definitions and the concept which are required for understanding the shear force and bending moment better. So without wasting time, let us move forward and start our discussion for today. So in this introductory video, we'll be saying some definition for first. So for that first definition which we need to understand, that is a beam. What is a beam is called? Okay, what a beam is called? Okay, so beam is basically a structural member that is acted upon by a system of external loads that act transverse to the axis. Okay, so any structural member where the transverse loads are applied, that structural member can be called as a beam. So let us understand it in a better way. Suppose I am drawing this is any structural member, okay, and I am applying some forces. So let this is P1 and this is P2, okay, so let this is P3, okay. So here we can see that in this structural member we are applied three transfer forces. Okay, so three perpendicular forces, that is these forces are perpendicular to the axis of this structural member. Okay, so I can show the axis of this structural member. So axis will be somewhat here. Okay, so whatever forces we have applied to this structural member, that those are perpendicular to the axis of this structural member. Okay, then this structural member which we have considered, that can be called as a beam. Okay, so in this way only the beam is differed from a bar, because in case of any bar where whatever we may consider, there we can apply any tensile force or compression force. Suppose let us consider a bar over here. So let me consider a bar. Suppose I am considering this is as a bar, then here I can apply any force in this direction or any force in this direction. So if we have applied the forces by which I have shown by the black line, then that type of forces can be called as a compressive force. Then we can call it as our bar is under the compression. Likewise, whatever force I have used by this color, then we can say that our bar is under tension. Okay, so in this way only, that is in case of our bar, our force is applied or the load is applied along the axis. That means along the axis we are applying the forces, but in case of your any beam, the forces or loads are applied perpendicular to the axis. Okay, so in this way our bar is differed from the beam. Okay, so I think you have understood this one. So let me erase all these things. Okay, so now in addition to the point of loads or uniformly, that is point loads or uniformly distributed loads acting transverse to its axis, a beam also loaded with a force couples acting in a plane passing through the axis of bar. Okay, so as I said, we may apply some forces that may be point load or that may be uniformly distributed load. That different types of load we'll discuss later. So in this video itself we'll be discussing about that. As I told you that the different types of load like point load or uniformly distributed load can be applied or can be acted on our beam, and likewise also force couples can be acted on our beam. Okay, so after understanding what a beam is, let us understand what is a bending beam. Okay, so bending means actually whatever load will be applying on the beam, due to that there will be some deformation. Okay, so deformation caused by that load which will be applied on the beam, then that is known as the bending. So let us read the definition over here. So bending implies the deformation of a bar produced by the loads perpendicular to the axis as well as force couples acting in a plane passing through the axis of the bar. Okay, so whatever loads or forces or couples will be applied, and due to that whatever deformation will be caused in that beam, then the deformation is known as the bending. Okay, so different types of bending may be occur inside a beam. So let us understand how many types of bending may occur inside any bar. So first kind was is your plane bending. So plane bending means what? Suppose let me draw a beam. So let us consider this is as a beam, and I can show the axis of that beam by this color. Okay, so this is the axis of this beam, and let me show the cross section of the beam. Okay, so let us say this is a square cross section of beam. Okay, so okay, so let us consider this is as a square. That means the side of this square, this is a. Okay, so if we will see the axis will pass through this center point. The center point I can locate, that means from the horizontal line we have to go up by a by 2, and from this vertical line we have to go to right side by a by 2 also. So by moving this we can find out this center point, and the axis will be passing through this center point only. So what a plane bending is, if we will be applying some amount of loads, some amount of forces, and if the line of action of those forces or those loads will be passing through the axis of the our beam, then whatever bending will be caused by those loads is known as the plane bending. Okay, so I think you have understood this one. So let me repeat these things again. Okay, so if we are applying some loads on any beam, and this the line of action or the line of action of these loads, if it is passing through the axis of the beam, then we can say whatever bending will be caused by these loads is called as your what? Plane bending. Okay, so now let us read whatever written over here. Okay, so beams are planar structures because all of the loads act in the plane of figure, and all deflection occur in that same plane actually. So this is the true, okay, which is called the plane of bending. Okay, and if the plane of loading passes through one of the principal centroidal axis, okay, so if it is the plane of loading passes through one of the principal centroidal axis of inertia of the cross section of the beam, then the bending is said to be the plane or direct bending. Okay, so then we can call it as a plane bending or direct bending. Okay, so now if it is not so, that means it is not a plane bending case, then we can say it is as a oblique bending. Okay, so let me erase all these things over here. Okay, so now if it is not a plane bending case, that means our whatever loads we are applying, that is not passing through the centroidal axis of inertia of the cross section of the beam, then it can be called as the oblique bending. Okay, so I think now you have understood all these four definitions. So with this idea, let us move forward and see how many types of loads are there. So as I just now told you that there is point load and distributed load. So first load type is your point load. So in case of your point load, as the name suggests, okay, our load is being applied at a single point. So it is assumed to be applied at a single point, and that can be called as a concentrated load also. That means our load is being concentrated at a single point. But in actual case, we cannot get this type of loads, because whatever load is being applied on any beam or any cross section or any structural member, it will occupy some area. So let us read it what is trying to say. So okay, so a point load also called as a concentrated load is the one which is considered to act as a point, act at a point. However, in actual practice, the load has to be distributed over some area, some definite area, however small it may be. So it may be so small, but it will require some definite area. So because such nice phase contacts are generally neither possible or not desirable also. So it is not required to be concentrated at a single point also, and it cannot be possible also. Okay, so it will definitely take some area to be acted. So point load, so we can generally say that if any load is being concentrated at a single point, then that type of load is called as a point load. Okay, so here let us see this example. So this is our structural member that we can call as beam. Okay, so these are two supports. We'll be discussing how many types of supports are there also in this video itself. Okay, so now let us focus on this type of loads actually. So load here, first one is W1, W2 and W3. First load, second load and third load. So all these three loads we can see that these are concentrated at a single point. So these three loads can be called as the point loads. Okay, so let us see next next type of load, that is our distributed load. So distributed, as I said, it will take some area over the structural member, and it will be represented or expressed per unit length. So if we'll see, so let us read it. Distributed loads are these loads which act over some area. Such loads are measured by their intensity, which is expressed by force per unit distance along the axis of beam. So let us see this example. Okay, so here we can say this is our structural member that is called as a beam, and from here to here our load is being acted. Okay, so it requires, so the perpendicular to the plane of our board, there will be some area which is being occupied or on which our load is being distributed. So but as we are taking the two axes, that is x and y, so here only along the length we are seeing the variation or distribution of the load. Okay, so our here distributed load can be represented along our length, that we can represent it in terms of force per unit distance, that is unit length. So here unit we can say that will be equal to Newton per meter. Okay, so again distributed load can be of different types. One is your uniformly distributed load, another okay, other one is your uniformly varying load. Okay, so in case of your distributed load, the magnitude of this load at each point may be different, okay, or may be same. So we do not have any idea about that, and there will be no variation linearly like that. So here may be the load value higher than this, again it will be it may be higher or lesser. Okay, so we do not have idea about this. Okay, but in case of your, so let us discuss about the uniformly distributed load now. So in case of your uniformly distributed load, which is abbreviated as UDL, so it is the one which has uniform intensity throughout the length. Okay, so it is being denoted or symbolized or expressed, actually we can say, that will be kilonewton per meter. Okay, so let us see the diagram over here. So if we see that comparable diagram, this one, when we are looking at the distributed load, so this curve, there will be a curve like structure, means we did not have any idea about the value of the load at each point. But in case of your uniformly distributed load, at each point along the length, we have the magnitude of this load is W kilonewton per meter. Okay, so throughout the length it will be equal up to which this load is being applied. Okay, so I think we have understood this one. So if you cannot understand it, then do comment your doubts in the comment section. I'll be happy to answer you. Okay, so next type of load we can see, that is your uniformly varying load, which can be abbreviated as UVL. Okay, so again in this case what will happen, from a lower value to higher value or higher value to lower value, it can be linearly vary. Okay, so if our load is varying in a linear way, then that type of load we can say that type of load we can call as the uniformly varying load. Okay, so let us read it. A uniformly varying load is the one in which the load intensity varies from one end to other. Okay, such as the W1 at A. So let me show the diagram. Okay, so Okay, so this is the point A, and so let me change the color. Okay, okay, so this is the point A and this is the point B. So if we'll see at this point A, we are having with the load value, load magnitude, that is W1, and the load value at the point B is W2. So from A to B along the length, our load value is varying from W1 to W2. Okay, so we can see over here that the W1 is having with a lesser magnitude as compared to W2. Okay, so this type of load is known as the linearly varying load. So in some cases I can also represent that our W1, where we can represent as 0, and W2 will be having with some magnitude. So let me show that with some diagram. So if I am drawing, this is our this is as our structural member with there is support, there is a support. So which type of support we don't know till now, so we'll be discussing later about this. So okay, so let me use another color to give the load. Okay, so at this point suppose I am telling W1, and let this is point A. I am telling that W1 at A point, that is let this as A and let this is A1. Okay, at point A1 W1 is equal to 0, and at point B let W2 is having some value. So we can apply the as this. Okay, so let me, okay, so we can have a figure like this, where at point A1 the magnitude of load is 0, and at point B it will be having some magnitude, that is let W2. Let W2 is equal to 10 kilonewton. Okay, that means here we can see our load is varying from 0 to 10 kilonewton along the length, then and varying in which way, that is in linear way. Okay, so here we can see this type of load is called the uniformly varying load. Okay, so basically we discussed about two types of load. One is your point load, another one is your distributed load. Okay, so under the distributed load, again we discuss about uniformly distributed load and uniformly varying load. Okay, so now let us discuss about, okay, another thing that can be also applied on our beam, so that is known as your couple. Okay, so what a couple is, I think you must have idea about this. So a couple, when two opposite, okay, so when two forces applied on a structural member which are opposite in direction with a same magnitude. Okay, so opposite in direction and magnitude is same and acting in a same plane, then that system of force we can call as the couple. Okay, so let me draw any structural member. Okay, so this is our the structural member, and let we are applying some force F over here. Okay, so let I am applying F over here in this downward direction, and I am applying another force, that is also F in the upward direction. Then here we can say the magnitude of these two forces are equal, that is F, and their direction is opposite, so that we can say this force, this combination of these two force will try to rotate this system, that is structural member, along the clockwise direction. Okay, so this structural member will try to rotate in this direction. Okay, so this type of system, or this type of force system, we can say as the couple. Okay, so here let us see the diagram. Let me erase all these things over here. Okay, so here we can see a couple can be also acted on any structural member, or here we are considering about the beams. Okay, so here the clockwise couple is being acted on this. Okay, so with this understanding, let us move forward and start our discussion, or try to see how many types of supports are there. Okay, so whatever just now we discussed about different types of what that is loads. Okay, so how many types of supports are there? So first type, if we will see, one is your, that is your hinge support. Okay, so in case of your hinge support, if we will see, so let me draw the any structural member, sorry. Okay, let me draw any structural member. This is our structural member, and this is the support. Okay, and here we have been connected to this one. So if this is, we can say, as a hinge support. So if we'll be connecting our beam to any hinge support, then it will allow the rotation. Okay, that means if we'll be trying to, okay, let me use another color. If we'll be trying to rotate this structural member along any direction, then it can rotate. Okay, so it will be allowing the rotation of this structural member. But if we'll be trying to apply some force in this direction or in this direction, then it cannot rotate it. Okay, sorry, it cannot move. That means it is not allowing the translational motion, but it is allowing the rotational motion. Okay, so here if we'll be trying to draw the resistances which will be offered by this application of this process, then we can say if we'll be applying any rotational motion, then there will be no resistance developed here. Okay, so but if we'll be applying this type of forces, okay, so if I am applying this type of forces, that is a tensile force, then I'll be getting a resistance force which will be developed over here along this direction. Okay, so let this is Fx, then I'll be getting a resistance, that is Rx. Likewise, if I will be applying any force in this direction, that will be let Fy, then I will be getting any reaction force that will be along this that is y axis, let that is Ry. Okay, so I'll be getting two reactions in this case of your hinge support. Okay, so let us read the I think you have understood all these things. So let us read the definition over here. So a hinge support is the one at which the beam is free to rotate, but the translational displacement is not possible. Okay, so now let us see the example, real life example where hinge support are used. Okay, so here you can see a bridge which is made of steel basically. Okay, the members of this bridge are made of steel. Okay, so in the next figure you can see that this two half of this bridge has taken up. Okay, so has been raised up. Okay, so how can it be done? Okay, so there will be where it will be connected. So those supports are the hinge supports. That means it is allowing the rotation about that support. That's how we can rotate whenever it is required. That basically it is when our ship is to be moved under this bridge, our bridge should be raised. Okay, so for this is one of the applications. So a number of applications are there in case of your for of the hinge support. So here you can see one of them. Okay, so now let us see towards the next support, that is our roller support. So in case of your hinge support, our translational motion was not allowed, but in case of your roller motion, there will be rotation as well as the translation motion can be possible. Okay, so it will be seeing the definition over here. So if the end of a beam is free to rotate about the hinge, and also translational displacement along the plane of rolling, the support is known as the roller support again, or it can be also called as the movable hinge support. Okay, so let us see one of the real life example for this. So before that, let us show the reactions which may be found in the case of a roller support. So roller support are basically represented by like this. So this is the roller support, and this is any the structural member. So let me show the structural member by a different color. Okay, so this is any structural member which is connected over here. So here what we said, if we will be connecting this one with this, then there will be a rotation. Okay, so rotation can be possible. That means this beam can be rotated about this support, and also it can be translated. Okay, so if we will be applying some force along this direction, then it can translate. Okay, so if we will be applying any force in this direction as it is translating, so there will be no reaction along this axis, axis, okay, x axis. Along the x axis we will not find any reaction forces, but if we will be applying any force along this, okay, that is along the y-axis, then we'll be getting a reaction force along the y-axis, that is Ry. So in case of a roller support, we'll be getting only one reaction force, that is along the y-axis, okay. And okay, so that is the thing. And if you will be applying the moment, so there will be no reaction, okay. So let me clear all these things, and let us see the real life example where we can have a roller support. So here you can see overbridge, okay. So under the overbridge, here this point, mark this point. So let me, okay, so see this point where you can see the roller support, okay. So why it is basically used? So basically in case of any bridges, we will be using the steels as the structural member. So steels have the property of expansion due to temperature variation, okay. So in case of your summer to winter, we will be having a temperature variation, okay. Due to this temperature variation, our steels may expand or contract due to the temperature variation, okay. So due to temperature variation, if our steels are expanding and contracting, then there will be a requirement of translational motion, and to achieve or to make happen that translational motion, will are providing this type of supports, that is roller supports under the bridges, okay. So I think it's clear to you now. So let us move forward and discuss another type of support, that is your fixed support. So I think you must have idea and must have seen all these type of supports. So fixed means there will be no movement, there will be no translational movement, or there will be no rotational movement about the support, okay. So whatever the structural members will be connected to the support, there will be no movement about that, okay. So there will be neither rotational is possible or translational displacement is possible, okay. Nothing is possible about that support, okay. So if we will be drawing that okay, let me use, okay. So let this is our support, and let this is our structural member. So let me use another color for drawing the structural member, okay. So let this is the structural member, and this is fixed at this point. Then if we will be applying some external force, let okay, let this is Fy, and let this is Fx, okay. So due to this force, will be having a reaction over here, okay. So let this is Rx, and again due to this force, will be having another reaction over here, that is, sorry, this is your Ry, and this will be your Rx. So due to both these two forces, will be getting the reactions, okay. Again, if we will be trying to rotate, if we will be applying moment to the our structural member, again will be getting the moment over here, okay. So let this is mx you are applying, then again here also you will be getting mx amount of moment, okay. So here reactions, you will be getting both the reaction along x and y, as well as moment you will be getting, okay. So I think you understood all this type of support over here. So now let us see one of the examples of the support, that is fixed support. So here you can see at this end, it is this structural member, which is a beam, it is fixed. Likewise in this end also it may be fixed. So this type of support, which can be fixed at actually, so there will be no translational motion, or there will be no the rotational motion is possible, then that kind of support is known as the fixed support, okay. So now let us move towards next, and let us discuss about different types of beams, okay. So first and simplest type of beam which we'll be discussing over here, that is simple supported beam. So what we can see, suppose let me draw it over here. So let this is our beam, and we'll be having some reactions over here. Let this is Ry, and so Ry, and let this is point A, and this point is B, and this is Ry at point A, and this is Ry at point B. So we'll be having, suppose this is the beam, and we are having two reaction at these 2 points, then this type of beam can be called as a simple supported beams. Okay, so let us see one of the examples. Okay, so here I have given you one of the examples. So here you can see this support is called as your hinge support, and this is your roller support. So in the roller support, I draw a diagram somewhat like this. Okay, so another type of roller support. Okay, so it can be also shown like this somewhere. Okay, so it is also correct. Again, it is also correct. Okay, so need not to be worried for that. Okay, so this is the hinge support, and this is the roller support. And if you will see, in case of your hinge support, you will be getting two reactions. So along the y-axis you will be getting reaction, that is Fy. Let this is point A, so I can write Fya. And along the x-axis also you will be getting the what reactions, that is let Fx A. Okay, but in case of your roller support, you will be getting only reaction, that is along the y-axis, that is Fy. Let this is B. Okay, let this is the point B. Okay, so as I discussed previously, that if there will be two reactions which are upward only, then and the what support that beam held by those type of support can be called as your simply supported beam. But here we can get that there is also a reaction along this direction. But if we see, there will be only a load which we can apply for a beam that is along the perpendicular direction to our axis. So axis will be in this direction, and whatever load will be applying, that should be like this. Okay, we can apply loads over like this. So there will be no horizontal forces can be there. So we can say, so that this reaction we can neglected to 0. So we cannot get any reaction along x-axis of the beam. So Fx will be equal to 0. So this type of beams are called as your simply supported beam. Okay, so let us move to next type of beam, that is our cantilever beam. So what is a cantilever beam? Suppose one end of the beam, if it is fixed. Okay, so let this is our fixed support, and we are holding this beam over here. So one end of this beam is being fixed over here, and another end of this beam is being free. Then that type of beams are called as the cantilever beam. Okay, so let us see the diagram. Let me erase this one. Okay, so this is the cantilever beam. Here one end of this beam is being fixed and other end is being free, and here load is being applied. So load can be applied anywhere, but the beam should be like this. Okay, one end of the beam should be fixed and the other end of the beam should be free. Okay, so let us move to next type of beam, that is overhanging beam. So overhanging, that means actually, so let this is the our what, that is beam, and we are providing the supports. Let there is a support, and this is let hinge support, and let there is a roller support. So I can do like this also. So this is the roller support, and from here to here there is no supports. Okay, so without support this much, so let me, okay, so from here to here we are not having with any supports. Okay, so this type of beam totally can be called as the overhanging beam. Okay, so if we'll be not having with this part, okay, so if we'll be considering only this part, then this can be called as your simply supported beam. But if we'll be considering the total one, whole one, then this can be called as our the overhanging beam. Okay, so let us see the diagram over here. So here if we'll see, sorry, okay, so here whatever diagram just now I drawn, so that was here. So this support is a hinge one, this is your roller one, then this total is called your the overhanging beam. Okay, so now let us move towards next kind of beam, that is your fixed beam. So if our beam is fixed between two fixed supports, then that can be called as our fixed beam. Okay, so let me draw again. So let these are two fixed support, and this is our beam which is held between these two. That means these two ends are being fixed between these two fixed support, then this beam can be called as a fixed beam. Okay, So nothing to understand about this, so simply you can get it from the names actually. Okay, so now let us move towards the figure. So here you can see, if this end is also fixed and this end is also fixed, then all this type of beams can be called as our fixed beam. Okay, so now let us move towards the last kind of beams, like continuous beams. So continuous beams means there will be a number of supports there. Okay, so it will be considering any structural member. Okay, let this is a structural member, and there will be number of uh, okay, there will be number of supports. Okay, then that kind this beam can be called as the continuous beam. Okay, so nothing to understand here. So continuous beam, if there is number of supports which is held there to which is there to hold our beam, then that can be called as a continuous beam. So let us see the diagram. Here we have a support, hinge support, and 3 roller support. Then this beam is can be called as our continuous beam. Okay, so all the overbridges are supported by number of our supports. Okay, by number of columns we can say also. So these are the supports which are there. So let me zoom it. Sorry, I think it's not clear to you. Okay, let me see whether it is possible or not. Okay, so here you can see the supports. Okay, so these are the supports over here. Okay, so now I think you understood all these things. So in this lecture we studied what a beam is, what are different types of bendings. Okay, what a bending is called. Then we discussed different types of beams, different types of loads. Okay, and different types of okay, so all these things we just now discussed over here. So for today this much we discuss. In the next class of shear force and bending moment diagram, we will discuss what a shear force is and what a bending moment is. Then we will be trying to assign the sign convention, and then we will proceed further. Okay, so thank you for watching. So before signing out, let me say one thing. Then if you like this video, then press on the like button which is given below, and if you are new here, then subscribe to our channel, and press on the bell icon, which is more important for you to getting the to get the notification whenever we'll be uploading any new video. So pressing bell icon is most important thing, so do press on the bell icon, and whatever okay, and another thing, do share it with your friends whoever requires it. Okay, so thank you for watching.